Hello everyone, my name is Aman and today I will be talking about our work on FedPandemic across device federated learning approach towards elementary prognosis of diseases during a pandemic. Pandemic, as given in the Oxford Dictionary, is a disease that spreads over a whole country or the whole world. COVID-19 was declared a pandemic by the WHO on 11th March 2020, making it one of the darkest points in recent medical history. While incurring tremendous loss in those infected and those killed by this pandemic, we also saw other effects of the novel coronavirus, including joblessness and an economic crash. The amount of data, manpower, and capital required to understand, evaluate, and agree on a group of symptoms for the elementary prognosis of pandemic diseases is enormous. And this was proven while we handled the COVID-19 pandemic, with more than 469 million euros spent within a year on research, out of which 88.3 million euros was spent on preparedness and crisis management, while 25 million on diagnosis. These two only within Europe. We can formulate the importance of symptom retrieval at the same time the speed as well as the precision of these symptoms becomes highly important. Therefore, we present five major points of concern with preliminary medical implementation during COVID-19 and would like to help support and replace them with our novel federated learning architecture for symptom prognosis. The following points of time consumption, logistic tools, client privacy security, costs for anonymization, and data bias become important. Prominent symptom detection is an integral part of pandemic management and control. If these symptoms are detected and retrieved at the earliest, the process of elementary prognosis will be facilitated faster. Therefore, a system which was concise, fast, and easy to implement would be both financially beneficial as well as easy to manage. On the other hand, contributor privacy over medical data must be a major point of concern, and a methodology which takes into account both privacy as well as being robust towards noise becomes important. With these points in mind, we came up with FedPandemic, a novel noise implementation integrated with cross-device federated learning for elementary symptom prognosis during a pandemic. Using the federated averaging algorithm, we employed our custom noise implementation during single client training, allowing us to train a binary classifier which is able to retrieve only the most important symptoms. Our client-level training requires a predetermined medical corpus of common symptoms, which is used to supply negative samples to the client model. The symptoms exhibited by the client act as positive samples, and combined, they're able to create a binary classification system. The use of arbitrary systems allows statically popular or significant symptoms to retain their predicted output across multiple clients during the aggregation step. Here is the algorithm we use for noise implementation. The use of the above methodology allows us to overcome some important issues of symptom analysis. 1. Manual aggregation of data from multiple healthcare centers is not required. 2. Common symptoms that would be easily identified by the public, such as high temperatures, fevers, would be given importance, giving the general public a better chance of discerning the infected. 3. Retains client privacy. 4. Word embeddings allow semantically similar words to be treated with prominence. This may aid researchers to additionally study other symptoms. Data. We use publicly available data from Statista to create a chart of a number of people displaying particular symptoms. This allowed us to accurately simulate the population. This is the histographic representation of the 10 most common symptoms displayed during COVID-19. We use these numbers to simulate in our experiments, taking these as part of our case study. Experiments. The experiments revolved around simulating 4 different kinds of environments, namely large medical institutes, medium range medical institutes, small range medical institutes, and finally the most important simulation, that is family or individual contributions. We were able to achieve the following retrieval results. Here showing some of the most popular symptoms identified as of now for COVID-19. As you can see, using uniform distribution, the noise federated averaging algorithm is able to succeed due to the statistical significance of these symptoms and the sheer number of people displaying them. However, the above implementation is from non-uniform sampling, and therefore we show results from a Laplacian distribution. As you can see, our methodology still holds for most simulations. There is prospect towards improvement, and trade-off must be reached between privacy and model accuracy for simulation 4. Conclusion and future work. FedPandemic offers an easy to implement privacy ensuring robust to noise solution towards speedy elementary prognosis. We believe the methodology can be employed by both medium and small range medical institutes, as well as a substantial group of symptoms must be aggregated to create a medical corpus. Also, we hope to improve and make our methodology robust against malicious attacks and Byzantine failures. Thank you.